See this problem. The wires which connect the battery of an automobile to its starting motor carry a current of 300 amperes for a short time. What is the force per unit length between the wires if they are 70 centimeters long and 1.5 centimeters apart? Is the force attractive or repulsive? Our motive is there is a starting circuit in a automobile, so which is connected to the battery, and later on it connected to an ignition switch. If you switch on the ignition, then there will be a current in that circuit. So somewhere else these conductors are laying parallelly and they are having opposite currents like this, and they are separated by some distance. So we need to find out the force per unit length on those two conductors. And we need to find whether it is attractive or repulsive. That is our motive. Now come to the investigation part. The current I is equal to 300 amperes throughout the circuit, but here we will consider it as I1 and I2. That is equal to I1 and it is also equal to I2. And the length of the conductor L is equal to 70 centimeters. And they are separated by a distance D is equal to 1.5 centimeters. That is equal to 1.5 into 10 to the power of minus 2 meters. Now come to the resolving part. The force per unit length for two parallel conductors can be written as F by L is equal to mu naught by 4 pi into 2I1 I2 by D. That is equal to mu naught by 4 pi is 10 to the power of minus 7 into 2 into 300 into 300 divided by 1.5 into 10 to the power of minus 2. 1.5 ones, 1.5 200s are 300. So 2 3s are 6, 6 2s are 12, 12 into 10 to the power of minus 7, 10 to the power of 2, and here also 10 to the power of 2. So it will become 4. So plus 4, and in denominator we have 10 to the power of minus 2. So if it goes to the numerator, it will become 10 to the power of 2. So I can write plus 2 here. That is equal to, here you will get minus 1. So the total value is 1.2 Newton per meter. This is the force per unit length for that parallel conductors. Now consider these two parallel conductors. So they have their own currents in different directions. Now I am considering I2's magnetic field. Using right hand thumb rule, I can describe the magnetic field of I2. So it will be in this direction. So it will act on the first conductor from downwards towards upward. So here the magnetic field direction is upward on this conductor. From Fleming's left hand rule, if your magnetic field is in upward direction and current is in right direction, the force experienced by that conductor will be towards this direction. So like that, on the second conductor also the same, it will be other direction, away from the other conductor. So it seems to be that it is repulsive force. So the force per unit length, which is 1.2 Newton per meter, is also a repulsive force.